All right, here we are. This is the Exsurgo Performance System. If you have not been using the Exsurgo Performance System, you may not know about some of the features that we have in here. The most important here is data analysis. Under the data analysis tab, we're going to pick one of our current athletes. This is her. Under this, you're going to have all these different reports: an athlete report, trends, jump analysis, RFD strength ratio, dynamic strength index, force velocity profile, eccentric utilization ratio. All this stuff is cooked in to the Exsurgo Performance System using data captured from all of our devices like the gFlight, gStrength, and gSprint. Using all three of those devices, we've come up with an assessment that we use. We take an isometric mid-thigh pull. We take an isometric mid-thigh pull fast pull to get that rate of force development. We compare those two. We also do a counter movement jump, a drop jump, 20-meter sprint with a 10-meter split, right? And without further ado, this is how we do it under the athlete report, under data analysis. All this data was captured using our devices. It's all right here. 1121 was the assessment. We'll just pick all four of those. We'll pick all of these. We'll pick all of these from the counter movement jump. It'll go through and pick the ones that have the best metrics. Here we go, a drop jump on 1123. We'll just pick them all. Here we are, we're picking a sprint. And we know that there's a split time. It's a 20-meter sprint. We put the split at 10 meters. Now we hit generate, and you get this snazzy report. Using their body mass, which was input under the athlete tab under their profile, it pulls their weight. It then takes the IMTP value, divides it, the IMTP value, by their body weight to give us a 1.77 relative strength ratio. This relative strength ratio is backed by validated science. I believe it was Sanchez and Medina from 2017, did a paper on that. You then are able to see that her RFD strength ratio, how much is she able to pull in under, look at this, 62 milliseconds. She was able to get 197 pounds. Compared that to her isometric mid-thigh pull, she's producing 91% of her maximum strength in under 200 milliseconds. That's great for an athlete. Could her relative strength ratio be higher? Possibly. Is that a determining factor? Maybe not, but what we're looking at here is a collection of information about this athlete, again, all captured using the Exsurgo Technology devices. Now we're going to look at the jump analysis. We're comparing her jump height, right? And from that, based on her flight time, that's how we measure it with the gFlight. It's flight time. We then take that and run calculations to give us the jump height. From that, you can extrapolate takeoff velocities, force, using the Sayers equation. Because this was a counter movement jump, we're looking at her wattage down here. We then compare the drop jump height to the counter movement jump height. And again, this is something that many platforms out there aren't giving you. They're not doing these relative strength ratios, RFD strength ratios. And now we're looking at drop jump to counter movement jump. Our system is more than just collecting a bunch of data and giving fancy little graphs. We're actually utilizing this data based on established research that has been published and looking at these ratios to create the athlete report. Now, here we are again, another one, hot topic, dynamic strength index. Everybody loves to talk about how much force one can generate from their isometric mid-thigh pull, counter movement jump force. Again, we're using equations to calculate this based on flight time. They are biomechanical formulas that are established and out there. It's very easy to do, and it's also easy to get wrong if you're doing it in Excel. We take all of that out for you and calculate it here in the dynamic strength index portion of the athlete report. Now, notice she comes out with this number based on published data for the dynamic strength index. These are the recommendations. Again, for her, maximal strength training. Kind of starting to see that maybe with the strength to weight ratio, maybe with her RFD strength ratio, or counter movement jump to drop movement jump, that's good. We are getting a profile of this athlete in areas that we can begin to focus on. Here is another one. 0 to 10 meters was in 3 seconds. 10 to 20 meters was in 1.75. You do the math on that, it comes out to 1.7. Kuki et al. From, I believe, another one from 2017 did studies on the first 10 meters and the second 10 meters in the 20-meter sprint. And they found that most of the high-level athletes had a 1.3. This came in at around a 1.7, 1.8. Again, areas to work on. How do we increase off-the-line acceleration? Strength. We're seeing tendencies, concurrent recommendations here. Her reactive strength index, 0.898. That is low. So again, what are we starting there? Strength and plyometrics. So some consistencies based on this data, all the data captured within the Exsurgo Technologies devices using the Exsurgo Performance System. No Excel needed here, no spreadsheets. Just click buttons, get recommendations, take those recommendations, build training plans with them to help this athlete improve and be the best that they can be. The Exsurgo Technologies, Exsurgo Performance System, Athlete Report. Make sure you check it out. Everyone has access to this. Want to know more? eps.exsurgo.tech.